Hi everyone, thank you for joining us today. My name is Kevin Weiner and I will be the moderator on this webinar. The discussion today will focus on how you can ensure consistent output quality for your geospatial products. Our speaker today is Rebecca Lassica, a Senior Solutions Engineer here at Axcelis Visual Information Solutions. Before I turn this over to Rebecca, one quick housekeeping note. If you have any questions at any point during the webinar, feel free to use the question area of your GoToWebinar dashboard. We will try to address as many questions as we can at the end of the webinar, and if we don't get to your question, we will follow up with you. Without further ado, I will turn things over to Rebecca.
Thanks, Kevin. Hoping everybody can hear me all right and see my screen. Remote sensing for oil and gas. So this is part 2 of a several-part series that we're doing for the oil and gas remote sensing industry, but there's a lot of crossover with the processes and applications with a lot of other industries. So I know a lot of you on the phone, they might be in a different sector, and we welcome everybody, and thanks for joining us today. We'll get started. Okay, so if any of you have been to my webinars before, you know that I don't have a lot of words with no pictures. This is not one of my typical slides, but I just wanted to put up here, we did something new with this webinar, and it is a Google Hangout. And we recorded that, and what was great about this is that based on the topic that we're discussing today, which is data quality assessment, we invited an expert panel to participate in a discussion as a Google Hangout. I highly recommend going to YouTube to watch that. You can get to this link from our website. And these are just some of the topics that were discussed during that Hangout. You know, just basically what are the data quality challenges and what to do to address those. And I've summarized it a little bit more concise in this next slide here. Our experts all agreed that these are the best practices and where data quality comes into play in their analyses, where standards are important, and we'll talk about that. A lot of people cited that survey projections versus the projections of the imagery that you might be using might be different, and how do we get everything aligned properly before performing analysis was a big topic. One of the other things that was highlighted is that a lot of times, you know, because remote sensing imagery can be expensive, what are the best practices to look at a large-scale area first to hone down a certain characteristic of interest or something that you're looking for before going into the fine-scale detail that might be require some imagery that might be of a greater cost. And with that, keep the area of interest small. Make sure the pixels are aligned. We talked a little bit about that. And a lot of the folks you know, in the energy markets do see remote sensing as a special subset of GIS, in that it's something that's been around for a long time, and it's very specialized to do things that can really, in the end, save money and time on analysis efforts. So what we're going to talk about today is step through some of the input and processing best practices when assessing and working with imagery. I'll show some examples along the way, so I'll be breaking out of this you know, PowerPoint and going into some demos kind of back and forth. And then we're going to perform a deeper dive in analysis workflow to illustrate some of the best practices in action. So for the example today, we're going to look at evaluating some vegetation and look at vegetation filter buffers, which I'll describe in a little bit. They're the zones between basically roads and waterways that are used to filter sediment from production, accidents, other hazards, or anything as it might apply. And before it intersects with a waterway like a stream, an open water body, things like that. And I'll get into more detail of the analysis in just a bit. But first, let's take a look at the best practices for data quality assessment of the input and the processing of the imagery. So let's start with the input. One of the most important things that we hear, and that we heard from our experts, you know, not just our customers, but also the expert panel, is that it's really important to verify that the data you're working with are already in the right place. Data resolution also plays a role here, where a 30-meter pixel data offset by a meter is a lot different than a 30-centimeter pixel off by the same meter. So accuracy is going to have a large effect on the end result. Additionally, most analyses these days incorporate more than one layer. So do the vector layers overlay on the features that they represent in your image? What about the overlay in Google Earth or on an ortho product that you have on maybe the base map? And let's jump out right away here and take a look here. I am going to go into ENVI. And I don't know if you're all aware, by the way, I'm showing our candidate new release of ENVI 5.2, which is scheduled for release later this fall, pretty soon. And I'll be highlighting some of the new features that we do have available in this release. And you may already be aware of this, but we do have the ability to go to remote connection where I could go out to an image service. And for this image service, I'm just going to go out to the NAPE image service. This is just a 3-band service, and download an image. So I'm actually going out to the web, out to the internet. I'm connecting to a REST endpoint, and I'm downloading that service into ENVI, and I'm bringing in, this is a NAPE image of Arizona. Okay, and then what I also want to do is I have, let's see, I've got a worldview 2 image, courtesy of Digital Globe, and I'm going to just open this up. And I get a little bit nervous sometimes when I'm connecting to image services and running some big data things while I'm on a WebEx, so hopefully, hopefully this works out. But let's jump to this layer. Okay, and it's going to just take a minute to come in here. So one of the things about working with satellite imagery, and this is pretty common, is, you imagine these satellites are how many miles away from the Earth, viewing the Earth from space, and the alignment is actually pretty good, but you can have some distortion. And with most modern satellites, the vendor is going to give you what's called RPCs. It's rational polynomial coefficients, which represent the geometry of where the sensor is when it's taking the image, so that if there is an offset, you can use those coefficients to back out that offset and get a better aligned product. And so we did that here, and I'm going to, at risk of stopping things up, I'll give some time for the WebEx to kind of catch up with what I'm doing here. But I'm zooming in to an area here. I'm going to open up a portal to look through the image that I've got on top to that NAPE image that we've got on the bottom. And you can see here as it comes in, there actually is an offset in the actual satellite image that we're working with the orthorectified NAPE image that we have that we're using as our base map. So what we really want to do is use those RPCs to actually align the image with our base map before we perform any analysis. I did that in advance just to save time. So I'm going to remove the original image, and I'm going to open my result. So this is my orthorectified result. Here's the same area, and you can see that the image did align. And so we use those RPCs that come with our satellite imagery to do that alignment, perform that alignment. RPC orthorectification is one way to do this. There's rigorous model orthorectification as well. So if this is something that you notice with your data, there may be something in your data that enables you to actually use it and see if you can get a better alignment before you do your analysis. I'm going to close this, go back to our slides for a minute. And let's see, we're here. Okay. Oh, that's fine. We'll just kind of get back to where we are. Okay, so here is basically I grabbed these screen caps to show you the before and after, just in case that demo didn't work. Okay, the other thing about input is that you've got to verify the data pre-processing level. Different vendors may give you an image product in different levels of pre-processing, so maybe the data have been calibrated and corrected for atmosphere, maybe they haven't. Sometimes they're clipped to be a color infrared image where they only keep a near infrared and green and blue band, or red and green band, depending, and not giving you all of the information that came with the original data set. You've really got to be aware of what you're working with. It's going to have a large impact on what you're able to do with it. What are some of the ways that we can figure out what it is that we're working with? Well, you can look at the pixel values. That can give you an idea of the type of data that you're working with. What do the spectra look like? And what you see here, what I can show in an example, is have the data been radiometrically calibrated? Have they been atmospherically corrected? And that means, is the sensor distortion and atmospheric distortion removed from the information in the image before you process it? And many algorithms perform to their best optimization, and also you're going to get more meaningful and meaningful results out of information if you put the right data in. And we'll look at those in a minute. So I want to break away here and just take a quick poll about quality assessment. What are some of the reasons that you do not perform, or maybe you do, data quality assessments on input data? So I think my colleague Kevin's going to launch that poll and let me know when everybody's answered. I'll give you a minute here.
All right, the poll's open, so if you want to go ahead and select the answer that's the best fit, we'd appreciate it. Give everyone a few more seconds to get their answer in. All right, so we're going to close the poll now. It looks like about 50% of people said, I always perform data quality assessment, which is great. Another 25 said, I'm not sure what needs to be done, and about 38% say, I do not have the proper tools.
All right, thanks for that, everybody, and thanks, Kevin. And we'll move on. So we talked a little bit about looking at the input. Processing is the other key area where we really need to look at data quality. And by processing, really it's define the processing workflow. So, the best practices that our customers have success with that we recommend is really you begin at the end. What's the goal? Got to figure out what it is that you're trying to do with the data. What is the answer that you want to have? And based on the input assessment, are pre-processing steps required to reach that goal? So are you performing some spectral analysis, meaning if you are, you probably need to calibrate and correct your data. What algorithms are required to achieve the goal? And then what data are necessary to run the identified algorithm? So if you are running some sort of spectral index that requires a certain wavelength, making sure that you have that wavelength available in your data, or going out and getting another layer of data in your data stack to perform the analysis at hand. And that comes into what data are available to do that, and really what needs to happen from point A to Z to achieve that goal. And that really talks to which steps in which order. And this is really important, especially in larger organizations with many analysts, but also even for smaller organizations whose analysts might wear many different hats and thus rely upon an internal standards approach with order processing and even naming conventions that we heard about in the Hangout, if you guys go ahead and watch that. So this link here that I'm showing is to a really interesting study about ensuring remote sensing data quality for oil and gas applications, and was sponsored by most all of the big players in the market. And the chart I pulled from the paper indicates that people and data are the largest elements that contribute toward understanding the subsurface. Thus, it makes really a lot of sense to focus on quality assessment in these two key areas. We do that by verifying that the data integrity is maintained, and then we also verify that the people are doing the same things in the same order to ensure that the output is of the same consistency and quality. Okay, some of the ways to do that is to run workflows where people may be prompted to run the right steps in the right order, building models, web-enabled geoprocessing services, meaning they go to a web page and just say, I want to get the answer, and the actual processing steps in the right order are taken care of behind the scenes. There's a lot of different ways to achieve this. That's really important. And before we jump into a deep dive demo, I wanted to pull a couple of examples of some of our customers who have put these best practices into action successfully and then published these studies in various journals. And I give the link here. This first one was a study using airborne imaging spectroradiometer for application sensor and AISA sensor to tell the difference between oil and water. And the problem here was that the oil-water spectral signature is very different compared, depending on the concentration of oil in the water. So for this study, they actually had to figure out which spectral bands or spectral information showed those different signatures, and then made training data based on all those different signatures to figure out what's really pure water and what's an oil-water mixture. It was a really successful study that they did here. Another customer, this one focused on an area where oil and gas operations were ceased many years ago in Malaysia. And they wanted to study to see if there were any detectable areas of hydrocarbon seepage by looking at the vegetation. And when they saw that there was an area that was affected by vegetation, they called that an infected area, or an area that was affected by seepage. And it clearly outlined a shift in the study area, that there were some areas that did have some seepage of hydrocarbons well after, many, many years after operations had ceased. This is a really interesting study. The link's there if you want to read that. What we're going to do today is we are going to put these best practices in action, first beginning at the end, where the goal is to achieve a map showing a vegetative filter zone. And what these filter zones are they're areas in between an operation and a waterway. So in this particular example, there's some streams. I used an image. It's a WorldView 2 data set in Colorado, and it is over on energy communications operations. It's not actually a facility operations, but the idea of the analysis is the same, so I went ahead and used this image. It's a pretty interesting image. And so we're beginning at the end. We want to figure out where are these filter zones and what are they. So depending on the slope between a road and a waterway, there needs to be a filter buffer zone of vegetation to filter sediment. So if there's any accident or something spills, any of the sediment will be filtered from that problem before it reaches the waterway. And the width of those buffers are different depending on the slope to get from the road to the water channel. So that brings us to what data do we need? We're going to need some imagery. We're going to need a digital elevation model, so we're going to need some elevation information. And we are going to use some spectral indices to extract vegetation information that might affect these operations. We're going to expose the indices to the end users, who are sure to run the right process in the right order, and look at, is it necessary to reproject any of the data layers, et cetera, things like that. When we do run the vegetation in the index, we're going to also look at some of the spectral indices that are new in 5.2. Some of them are really interesting for this data set, and I know there are a lot of people on the phone who may have varying degrees of interest, so I'll try to cover some of that. Okay, and I'm a little reluctant. I was a little reluctant to include this next slide or not because it's pretty ugly, but the processing to get the data into the right layers in the right orientation, they're all aligned, everything's been calibrated. There were a lot of steps, and a lot of that I did prior to the webinar. And in a real-world example, a lot of the stuff that I did in advance, I would probably just run as a batch process, so I wouldn't do these one step at a time. I'd probably just wrap it up as just a process to click a button and go in this order. Basically, I verified the data location. I reprojected everything to actually match the vector layers. A lot of times vector layers come in state plane coordinates when imagery usually does not. And I find that the reprojecting of the imagery works just fine. A lot of people like to keep their vector layers in their state plane feet coordinates, so it's not a problem to just match the imagery to that. Data calibration, create a subset, atmospheric correction. I also found a slope map, which I'll probably just do live. It doesn't take long. And we'll look at these spectral indices. One thing I also plan to do, I know some of you are interested in ENVI programming. I do have an ENVI extension. I promise to those of you on the phone who are not programmers or have no interest, I won't spend more than 2 minutes on it, but I do want to show it because it's one of the really great new things that we have in 5.2 coming out, the ENVI task, and I want to make sure to highlight that. So we'll just spend a couple of minutes on that. Okay, we're going to end up with a pretty map. I'll show you how we get there, and we'll talk about what this is at the end. So this is just an overlay of the WorldView 2 data set. In Colorado, I verified the data location by just exporting it to Google Earth. And I use these tools to run radiometric calibration, atmospheric correction, and reprojection. So these are just all tools, just buttons in ENVI that you just click, and you kind of click through and click OK, and then you've got your output. So this will take care of a lot of that back-end stuff for you. And then I also use this, here's some links to the information that I use to figure out what width do these filter strips need to be, so I didn't just make them up. And it's based on, as you can see, the percent slope between the road and the stream needs to have a width of a filter strip of these varying levels in feet. Okay, and this is the study area that we're going to look at. On the right, the 3D surface view. I don't know if you all are aware that ENVI does have the capability to just drape an image over your DEM, but it's pretty neat, and you can put your vectors on there. They make really nice exports to presentations or maps. It's kind of a neat thing to do. Anyway, so let's jump in. All right, we're going to go back to ENVI. Okay, so what you see here is the WorldView 2 data set and the DEM. And this WorldView 2 data set was courtesy of Digital Globe. The DEM I downloaded from NSF OpenTopo, and I can give the link afterward if anybody's interested. It's a really good source of LiDAR data that you may already have LiDAR coverage, or there may already be LiDAR coverage for your study area if it's something that you are interested in. And then I used ENVI LiDAR to process it and create a DEM. And as you can see, I've got some overlap here, where if I'm going to turn off both these layers, you can see my area of interest is right at the kind of edge of where these overlap. So I'm kind of lucky there. And I'll zoom to those layers. So you can see that here's my study area. Here's my DEM. And then I've got some new roads in green, existing roads in red, and my streams in blue. So put those over the DEM, you can kind of see it better. So that's what we'll be working with. Okay, so the first thing that we need to do is figure out what are the slopes in these areas. And to do that, I'm just going to run some topographic modeling on my DEM, which is right. No, it's not it. Here it is. Okay. Oh, actually, that's going to be the huge one. Subset down. Where's that data? There it is. Okay. Okay, so I have the ability to run a lot of different topographic modeling algorithms here. The one I really care about is slope degrees, because that chart gave me slope in degrees, and that's what I'm going to threshold on. And I'm just going to output to my DEM slope degrees. So it's going to go ahead and run that. I wanted to show you one other thing about data assessment before I forget when this is done. Okay, if you go ahead and right-click on any file, you can look at the metadata, and a lot of times it'll tell you if something has been done to that data, so you can kind of know if it's been pre-processed. It'll give you the map information, coordinate system extent, so you can kind of get a lot of information there as well while you're doing your assessment. So that's just an aside. And then what I can do here is I can create some thresholds on my slope. I'm going to close all of the defaults, and I'm going to open some new colors where I think it was under 25% slope was a certain width, 25 to 30 was another, 30 to 40, kind of get where I'm going, 40 to 50. Okay. So all the red, I don't really mind all these areas that are under 25-degree slope because those are all going to be a 50-foot buffer according to my chart or less. So 50 foot's the minimum. I'm going to turn those off. And what I really care about, I care about these areas that are blue and green and yellow. So if I go ahead here and I kind of zoom into this area, I can see, and if I'm going to put my stream up here, maybe I'm going to turn it red so you can see it. Make it a little thicker. Okay, so you can see my stream. So some of the areas have a steeper slope, especially these yellows, 40 to 50-degree slope, where I'm going to need a wider vegetative filter buffer, filters on there. And so what I did here, and this is probably where most of the time for the analysis is going to be spent, is you can really just make a new vector layer. It's a new vector. It's going to be a polygon. Try that again. I think that worked just fine. So anyway, I'm just going to kind of make a little polygon around this area with that steep yellow slope. And I'm going to go through my image and do this to find my areas of slope of varying degrees. And once I have all those, I can go into my data manager and I can select all these different zones that have these different slopes, and I can just open them in ArcMap. By clicking this button, it's going to just open in ArcMap. I already did that in advance, so we won't have to spend the time opening another application. I just have it right here. Okay, so here are my streams, and you can see that I have buffer zones created based on the slope that I just used the geoprocessing buffer. I said for the layers that are 0 to 25 degrees, make that buffer 50 feet. If it's 25 to 30, make that buffer 85 feet, etc. And you start to get areas like this where you've got different zones of different widths having, or different zones with different slopes having a different width for the buffer. Then what I did is I just dissolved all those zones together and then saved it out as a shapefile to export back to ENVI. Okay, so if there are any questions on any of that, please do ask at the end or put in a question. We can address this further. I'll leave this open in case there are questions. Okay, so now I've got my buffer zones, and I'm going to turn all this off. I'm going to zoom back to this layer, and I'm going to just open. I think I already have it all. Okay, so these are the buffer zones that I had created. Okay, so the next thing that we're going to do is I'm just going to close these layers. If I remove them from my view, I'm not closing them in ENVI, they're still open. I'm just not going to look at them right now. And I'm only going to look at my WorldView 2 data set. And I'm going to load the color infrared just because it's interesting. The vegetation is going to kind of pop red. I'll maybe change the stretch. Okay. So now we want to do some vegetation analysis or look at some spectral indices. And one of the things that you can do is you can open the new spectral index tool from the user interface. And as you'll see, there are now 64 spectral indices in ENVI. And some of these are new. They're all documented with not just the map that we're doing, but also usually a link to a paper describing the science behind what's happening with that index. We also got some indices that, from Digital Globe that we included here. You'll see these WorldView indices down here, like a build-up index, things like that. what I actually did, instead of putting my input file and then running one of these at a time, I want to actually find a way to figure out, based on the data that I have, what indices are appropriate for the wavelengths that I have in my data, and then go ahead and run those. So this is the part where I'm going to just take an aside. I'm going to open IDL and show the new ENVI task. And what's so exciting about the ENVI task is, if you're familiar with the ENVI API before, or if you're not, you don't need to do any of the overhead of figuring out, passing around file IDs, or passing around spatial extents, or number of bands and the samples and lines. ENVI is smart enough to do that for you under the hood. So I'm going to call two ENVI tasks here. This one and this one, you can see it's just one line of code that says I want to run this task to query spectral indices. And what this does is it looks in the file that I pass in, and what wavelengths do I have? And then when I execute it, it's going to say, do I have wavelengths for this task? What about this one? What about this one? Through all 64 indices, and then return me an array of all the ones that are appropriate to run for that data set. Then with that information of the tasks that are appropriate, I just pass it in to this spectral index task and say, run the ones that are appropriate, and then add them to my layers that are available in my data manager that I have. The other thing, if you're not familiar with adding a button to ENVI, all you need to do is click this button that says New ENVI Extension. I'm just going to call it My Extension. And you'll see that it creates all of this wrapper code for you, that all you need to do is plug in the call to your tasks right here. And then the next time that you start ENVI, you'll have a new button in your interface that you can use to do something custom. So it's really, hopefully we're getting to the point where this is approachable to everyone, most everybody, to implement in their workflows. Note too that if you are an ArcGIS user and you want to run these ENVI tasks from within ArcGIS, the ENVI tasks are available if you have ArcServer. And then if you're building models and you just want to drop a task in there, you can do that as well. So if you want more information on that, just let us know. So you can see that I ran that, I restarted ENVI, and I've got this button here that I added called my Vegetation Index Calculator. It should really probably be called the Spectral Index Calculator. But I'm going to go ahead and run it. I'm going to give it my Worldview 2 calibrated subset. And what it's doing is it's going and figuring out which indices are appropriate, passing that to that task that actually runs the indices, and it's doing that here. This doesn't take very long. And what you'll see in a minute here okay, so it's just displaying the first one. Okay. So it created this ENVI temp file. I'm going to make this data manager a little bit bigger. And you can see it ran all these indices. And what's really useful at this point is if you are just getting the idea of exploring your data, you want to do something with it, and you don't know which index is going to pull out a feature or really separate the feature from the background that you're trying to extract or highlight or do something with, you can walk through and look at these indices in individual details. For example, maybe one of the things you want to do is delineate new roads or dirt roads as they're created. And one thing that's good for that is an iron oxide index, which looks at iron content. You can see that these little roads are starting to pop. This is Worldview data, and there's a new iron index that I could look at that one as well. Oops. Okay, I loaded that as a true color. And you see that they pop a little better even. So you can kind of go through and look at these different indices. I'll leave these open, so if there are questions at the end and you want to look at a particular index for this particular data set, we can take a look at that. But it's really a neat tool to have. What we're going to work with is an NDVI or a soil-adjusted NDVI. So I'll show you the difference here. All right, here's my NDVI, and this is a normalized difference vegetation index. If you give it reflectance data, which we did, then it does a good job of really delineating the healthy vegetation versus unhealthy vegetation, and really versus dirt and non-vegetation too. And that's going to be really useful in calculating how much vegetation that we have inside of these zones that we're interested in. The soil-adjusted vegetation index is actually pretty good in looking at vegetation that may be in areas with a lot of exposed soil like we have here. And a lot of times an NDVI might oversaturate, and this is one of the ways to kind of call that problem. These are pretty similar, as you can see. If I were to zoom in and take a closer look between the soil-adjusted and the NDVI, soil-adjusted NDVI, we're not going to see a lot of difference, here. But once I apply a color table, the differences may pop, and you can kind of just play with this as you see fit. Color table here. And then kind of see that there are some vegetation differences between the indices. So you can kind of just play with those. But for now, we're just going to remove these. And I have that filter buffer. So what if I take my data and I want to, I can type, I want to make a map. So I'm going to subset my data. I'm going to subset just one of these spectral indices, and they all come out as a band in the same file. So say that I take my NDVI or whatever else that you're going to work with, and I want to subset that particular band with my buffer zones. And I'm going to mask my background to not a numbers, so they're just going to kind of be see-through. And I'm going to output it to with my result. Just send it to a file. And obviously, if you have naming conventions, those are going to be pretty important to adhere to. And then what you can see here, if I zoom out and I turn off my my layers of my indices, you can see that I only process inside of my buffer zones. I'm actually, instead of having a base map of my worldview data, just because it's going to be easier to see, I think I'll put my my DEM there. I'm having trouble finding my DEM again. There it is. Okay, and I'll put this beneath my result. Okay, and then the other thing that you can do to pull out the results a little bit better is apply some colors to them. And I actually saved a color palette, I believe, not sure where I saved that. All right, well, I can't find it. It's easy enough to create. So if I want to make a color palette here, and I say everything from 0.2 to 2.4 is the areas I'm worried about. 0.24 is dry vegetation, but still it's veg, and maybe we'll go to 0.3 where it's healthy. 0.3 to 0.5 is very healthy, and 0.5 and above is extremely healthy. And you can go ahead and change some of these colors. Maybe I want varying shades of green for my vegetation. You kind of get the idea. Okay, so once this is done, and we've got our result, I think I saved my result off here with those other color tables that you saw on the map. Again, I can export this directly to ArcMap or just add it and then start creating a map. Oh, sorry about that. So yeah, I'm running ENVI in 64-bit mode, and to have the ARC interoperability, you've got to run in 32-bit. So the ENVI for ARC, which is, I'm just going to show you where that is. When you've got ENVI, you'll have ENVI for ArcGIS, and that's going to be running in 32-bit, so you can use that button. But we did that in advance, and we created our nice map. We're going to go back to our slideshow here and kind of recap. Okay. So first we looked at the topographic modeling. Then we created our vegetative filter zone buffers. And we processed our Worldview 2 imagery. We did some spectral analysis. And we applied those results to the output, exported to ARC, and we made a map. I'm not going to spend a lot of time in the map making today, but that is basically the way that we did that for now. So with that, I would like to put up another poll. So in terms of customizing your existing applications to perform some specialized tasks or workflows, and then you can see the answers. I think Kevin, my colleague, is going to put up those poll questions now.
All right, the poll's open, so go ahead and answer the question so we can see what the results will be. Looks like we got some good results coming in here. We'll give everyone about 10 more seconds to answer the question. All right, so let's go ahead and close it. It looks like we have a tie here with about 44% saying at least one person in my organization produces custom tools, and 44% also saying this is something I wish we could do more, but it's too difficult, time-consuming, or there's some other issue. So very interesting results there.
Okay, thanks for that, Kevin. And with that, I want to leave a few minutes for questions. We'll conclude the demonstration portion of the webinar and open it up for questions as they come in. I think that, Kevin, you're going to read off questions and we'll kind of work through them. I want to give a special shout out to my colleague Joe Peters, who created that beautiful map for us today. Thanks, Joe.
All right, Rebecca, are you ready for the first question?
I'm ready.
The first question is, do you have the ability to access image processing capabilities from a web front end that is maybe doing many additional things?
Yeah, so basically, I'm guessing that question probably came from when I was describing accessing geoprocessing tools from the web. We do have that capability. All of ENVI's API is pretty much accounts for 90+% of the functionality in ENVI. That can be called through either an IDL application or one of those ENVI tasks as a web-enabled geoprocessing capabilities. If you've got some advanced analysis that you want to do from you know, you've got a web portal your customers go to, or maybe somebody in your organization has a you know, complex program that wants to call into the ENVI capabilities. We certainly do have that available. That's called ENVI Services Engine if you want to look at that more on our website.
Great, we have a few more questions that have come in, and just as a reminder, if you have additional questions you'd like to ask, go ahead and use the GoToWebinar toolbox up at the top. So the next question is this presentation available to any of us on the phone? So I'll start by answering that, and then Rebecca, you can add on top. The webinar is being recorded, so you all will have access to that recording. It'll be up on our website shortly. And Rebecca, I'm not sure if you wanted to address the presentation versus the recorded webinar.
Yeah, so the presentation itself, if you email me, I'm happy to make this available. You know, screen caps, and I do have a talk track with it. So if somebody in your organization has any interest and was not able to attend or doesn't have the means to watch the webinar, I can certainly make that available. We also usually, in addition to the Google Hangout that we'll be doing in advance of these webinars, we will be putting out some resource like a white paper or something like that after the webinar that you can use to distribute internally or for your own benefit as well. So look for that on our website as well.
Great. The next question is, what is a good source of LiDAR to produce 1 meter or any other high-resolution surface like you used in the demo?
Okay, so LiDAR, so I mentioned NSF OpenTopo, and that's a really good website for existing LiDAR. A lot of times the point cloud density is pretty low for those data sets, but using something like ENVI LiDAR really to process to a 1 meter DEM or surface model, DSM, that's really sufficient. It's fine for those geomorphological products that you need. The low resolution LiDAR is fine. If you're doing feature extraction or something like that, where you want to pull up buildings or trees or power infrastructure or anything like that, you probably need a higher point density. There's some other sources for that, usually private vendors or something of that nature.
All right, looks like we have one more question that's come in. How do I access the ARC integration you showed? I don't see that on my system.
Oh, so if you have ARC and you install ENVI, the ENVI tools and ENVI capability will just show up. So if that's not something that you see, maybe you don't have an ENVI license, or maybe they were installed out of order, I'm not sure. If you're still having trouble, you can call tech support, but it's really automatic. If you've got ARC and you install ENVI, we are integrated to the extent that you will see the ENVI tools inside of ARC, and the ability to drag and drop and push files like I was showing very easily. So that's just all integrated and automatic.
Great. I think that's all the questions that we have. So I want to thank everybody for joining us on the webinar today. As I mentioned, a recording will be available on our website, www.excelisviz.com. If you have any additional questions, feel free to reach out to us. Rebecca, I don't know if you want to put up that last slide. There we go with all our contact information. We're happy to answer any questions. So thank you all for joining us.
Thanks, everybody.